coins in your pocket look simple, small, ordinary, forgettable. But what if I told you every single one of them has survived conditions that would destroy most everyday objects? We're talking about furnaces hot enough to melt glass, pressures powerful enough to crush a car, and yet these tiny metal discs come out the other side perfectly intact. On Factory Flow, we take you inside the extreme manufacturing process that turns raw metal into something you use without a second thought every single day. From feeding parking meters to grabbing a cold Coke from a vending machine, coins are still strangely essential in a world going digital. And here's the part that sounds unbelievable. It actually costs more to make a penny than the penny is worth. So how does that make any sense? This journey begins at the US Mint, where coin production starts on a massive scale. What you're looking at aren't just metal rolls. These are giant metal coils, each stretching nearly 1,500 feet. The coils come in different colors because each coin is made from a specific metal formula. Those formulas determine weight, durability, and even how the coin sounds when it hits a surface. The coils are lifted from storage and mounted onto powerful turbines. As they slowly unwind, thick metal sheets are fed forward into a heavy-duty pressing system. Even with advanced automation, human specialists stay close. Metal sheets can twist, jam, or resist being fed cleanly. This isn't a process you leave completely to machines. Once the sheets enter the press, there's no hesitation. The machine hits with extreme force, cutting perfect circular blanks from the metal, similar to a cookie cutter but on an industrial scale. The result? Up to 14,000 blank coins every single minute. And this is only the first stage. On Factory Flow, you'll see how these flat metal blanks are transformed into fully detailed coins. Precise, durable, and built to survive decades of circulation. Mint workers know exactly when the blanks are coming, not because of a signal, but because of the sound. The machine produces a sharp, rhythmic noise as thousands of metal discs shoot out in massive batches, filling containers in seconds. But the blanks aren't the only thing coming out of the press. On the opposite side, enormous piles of oddly shaped metal scraps begin to grow. The pieces twist and overlap, forming chaotic mounds inside huge bins. Some workers even rake them aside, the way leaves are cleared in autumn. This leftover metal is known as webbing. It's everything that remains after the circular blanks are punched out. None of it is wasted. Every fragment is collected, shredded, and recycled back into the system. At this stage, the discs finally resemble coins, but they're still incomplete. They already have the correct thickness, but their diameter isn't quite right yet. That final precision will come later. For now, the blanks are about to face one of the harshest environments in the entire process. The furnaces are prepared. Nearby, tanks filled with a special, slippery liquid stand ready. This stage is called annealing, and it's one of the most extreme steps in coin production. It begins with fire. The blanks pass into a massive furnace where temperatures climb to an incredible 1,600 degrees Fahrenheit. The heat is so intense that anyone nearby keeps a safe distance. This extreme temperature softens the metal, relieving internal stress caused during cutting. Without annealing, the coins would crack, warp, or fail when stamped later. Only after surviving this fiery test are the blanks ready to move forward. The process doesn't get easier from here, and somehow they come out without a single scratch. Despite the extreme heat, the coins emerge looking untouched. That's because the annealing furnace contains no oxygen. Without oxygen, the flames are carefully controlled, preventing the metal from tarnishing or discoloring. Even so, the coins are still dangerously hot enough to cause serious problems if they touch anything else. That's why the moment they leave the furnace, the glowing discs are rushed into a special water treatment. This isn't ordinary water. Water is only the base. On its own, it wouldn't clean the coins properly, and worse, the hot metal discs could fuse together permanently. To prevent that, the mixture contains a few carefully chosen additives. The first is citric acid. Yes, the same acid found in citrus fruits like oranges and pineapples, though you won't find any fruit inside the mint. By the time it arrives here, the acid is in powdered form and ready to work. Citric acid loosens dirt and residue from the coin surfaces, giving them that clean, freshly minted look. But it has another critical job, especially for pennies. Modern pennies are made from zinc, coated with about 2.5% copper. During heating, copper oxide forms on the surface. The citric acid removes that oxide without damaging the copper itself. That's what gives brand new pennies their familiar shine, at least before time and circulation take their toll. There's one more ingredient in the mix: lubricants. These prevent the coins from sticking to each other as they rapidly cool down. Without them, the coins could clump together and become unusable. Once the heat is fully quenched, the coins are no longer hot, and they're finally ready to be washed. But this step depends on where you are. The US Mint operates multiple facilities, and each one has its own method. At the Denver Mint, the process involves a massive scoop known as a skip basket. It lifts huge batches of coins out of the slippery solution and transfers them directly into the washing area, preparing them for the next phase of their transformation. And the journey isn't finished yet. At the Philadelphia Mint, the process looks a little different. Instead of a scoop, the coins are moved through a slowly rotating whirlaway machine. It gently guides the coins forward, but the result is the same. They're carried safely into the washing stage. Here, the coins pass through a specialized cleaning system. A precise mix of detergents and anti-tarnish agents restores their original color, removing any remaining residue from earlier steps. Once cleaned, the coins are thoroughly dried. Now it's time for one of the most important steps in the entire process: the upsetting mill. Earlier, the blanks weren't quite their final size. This is where that gets fixed. The coins are fed into a narrow groove, slightly smaller than their current diameter. As they move through, the metal at the edges is forced upward, forming a raised rim around each coin. This rim isn't just cosmetic. If the rim isn't formed correctly, the coin can't move forward in production. More importantly, the rim protects the design during stamping and helps ensure the coin wears evenly once it enters circulation. After leaving the upsetting mill, the coins reach a critical checkpoint. Mint workers now have trays of coins laid out in front of them, hundreds at a time. Their job is simple but crucial: inspect every batch carefully. They check that the rim is present, properly shaped, and that each coin meets exact size specifications. This inspection serves another vital purpose. It's the first line of defense against counterfeiting. As online marketplaces grow, so does the demand for collectible coins. Criminals attempt to exploit inexperienced buyers by flooding the market with fake coins. Because of this, an increasing number of counterfeit coins are being intercepted at US ports of entry. And it all starts with spotting the smallest details. Details that only a correctly manufactured coin can have. In 2020 alone, authorities uncovered a massive counterfeit operation in Chicago, worth $1.64 million in fake coins and cash. Cases like this highlight why precision matters. Without strict design and size standards, the Mint would practically be inviting counterfeiters to flood the market. When a batch passes inspection, the coins move on immediately to the next phase. They're guided through a funnel system that directs them deeper into production. Certain coins continue straight ahead, while others are sent for an additional cleaning process known as burnishing. During burnishing, workers place the coins inside a rotating drum, filled with cleaning agents and tiny metal pellets. As the drum turns, the pellets gently polish the surface, smoothing out imperfections and giving the coins a refined finish. These coins are handled with surprising care. After the process is complete, mint employees rinse them thoroughly, and in some cases, even dry them by hand using towels. It's a level of gentleness that feels almost out of place in an industrial environment. But that calm doesn't last. Now it's time for striking. The planchets, still blank but perfectly prepared, enter the striking press. This machine is responsible for creating the designs everyone recognizes instantly. This is one of the most dramatic moments in the coin's entire journey. The press stamps both sides of the coin at the same time, forcing the designs into the metal with immense power. For everyday circulating coins, the pressure ranges from 35 to 100 metric tons, depending on the denomination. And that's just the beginning. For collectible coins like the America the Beautiful 5-ounce silver series, the force jumps to an astonishing 540 metric tons. Most circulating coins are struck once, whether they're pennies, half dollars, or dollar coins. One powerful strike is all it takes to permanently imprint their identity. From here on, there's no mistaking what they are. Proof coins like the iconic American Eagle series go through an even more demanding process. Instead of being struck once, they're pressed at least twice, creating sharper details and mirror-like surfaces. And this isn't a slow operation. Each press can strike up to 750 coins per minute. Multiply that across the mint's machinery, and the scale becomes staggering. The Philadelphia Mint operates 63 striking presses while Denver runs another 54. At full capacity, Philadelphia alone can produce over 47,000 coins every minute, with Denver close behind at more than 40,000. But power isn't the only thing making this possible. Every striking machine is fitted with a solid metal collar. The planchet fits snugly inside it, held firmly in place by the raised rim formed earlier in the process. This small component is absolutely essential. Without the collar, the metal would spread outward under pressure, flattening into a pancake. Before collars were introduced in 1828, coins were wider and far less practical to carry in large numbers. Thanks to collars, coins became thinner and more compact, without weakening the metal itself. In fact, collars allow modern coins to be thicker instead of wider, which is why dimes and quarters can maintain their current composition of 8.33% nickel, with the rest made of copper. After hours of non-stop production, one of the most satisfying sights in the mint appears. Massive piles of finished coins roll off the conveyor belt and drop into waiting bins. But even now, the job isn't finished. Inspectors periodically pull samples to ensure every detail of the design is correct. If even a small error is found, the entire batch is rejected. Rejected coins are sent to a machine known as the waffler. The waffler bends the coins into a crisscross pattern, making them impossible to use as currency. The damaged metal is then recycled, or sometimes sold as collectible curiosities. Without these careful inspections, counterfeiters would once again have an opening. The coins that pass inspection move forward to the final steps. They're counted, weighed, and packed into enormous bags. When filled, these bags are so heavy they can only be moved by forklifts. The forklifts stack them onto towering shelves, where they'll sit until the Federal Reserve places an order. That wait can be longer than you'd expect, and with the future of the penny still uncertain, these shelves may not hold them forever. So the next time you spot one, take a closer look. Because that tiny coin has survived fire, pressure, precision, and an incredible journey just to reach your hand.